Hey everyone, we're continuing with section 1.5 and quadratic equations. So we're going to focus on how to solve a quadratic equation. So to begin, a quadratic equation is an equation such that ax squared plus bx plus c equals 0, where our a and b and c are real numbers and a does not equal 0. So this type of equation actually models parabolic graphing. So if you have done pre-calculus or just algebra or parabolas like this, these are the kind of equations that model them, and we'll learn more about those later in the course. So our zero product property is kind of what we've been doing already, but this states that if a times b equals 0, if and only if a equals 0 or b equals 0. So that's like when we have our equations like x minus 6, x plus 2 equals 0. So this is like our a, and this is like our b. So equals 0, and that's why we're able to set each factor equal to 0 because of this property. So it only works if one side of the equation equals 0. So you can't have x minus 6 times x plus 2 and then set them both equal to like 1 or something like that. So we're going to solve an quadratic equation by factoring. So we have 2x squared plus 7x equals 4. So we want to get 0 on that right-hand side. So we're going to go ahead and subtract 4. And then we get 2x squared plus 7x minus 4 equals 0. So I have my 2 times negative 4 is our negative 8 up here. And then I keep the 7 for our x method of factoring. And then I have 8 times 1, and then I'm going to go ahead and set the negative on the 1. So that gives me 8 times negative 1 equals negative 8, and 8 minus 1 equals 7. So I have 2x squared plus 8x plus negative x minus 4 equals 0. So we're going to go ahead and group those terms. So I'm going to factor out 2x from the first to get x plus 4, and then factor out a negative 1 from the second in order to match that inside x plus 4. And then now we could do our zero product property. So we could set 2x minus 1 equal to 0 and x plus 4 equal to 0. So we get x equals 1/2 and x equals negative 4. So go ahead and check those solutions on your own in the original equation. So our square root property is if u is an algebraic expression and d is a positive real number, then u squared equals d has exactly two solutions. So if u squared equals d, then u equals square root d, or u equals negative square root d. So u is plus equal to plus or minus square root d. That's because if our u was plus or minus square root d, when we square that, we're going to get, for either one, let's do plus first. We're going to get d u squared, and then here the squared cancels the square root, and then our negative 1 squared is positive, so we get d. Okay, so our example is 3x squared minus 15 equals 0. So we're going to go ahead and move 15 to the right by adding it, and then we get x squared equals 5. So by taking the square root, we cancel that, and then we square root that side. So we do one side to the other side. So we get x equals square root 5 or x equals negative 5. So we could write that as x equals plus or minus square root 5. And go ahead and check your solution in the original equation to make sure it checks out. Okay, so here's a method called completing the square. So typically we don't use this method too often, and it's just for certain equations that you need to use it for, but I'm going to go ahead and go over it because that's how we actually derive the quadratic formula from the quadratic equation. So if x squared plus bx is a binomial, in order to make a perfect square trinomial, we're going to go ahead and add b over 2 squared, which is the square of half the coefficient of x. So we go ahead and add that to both sides. So whatever you add to one side, remember you have to do to the other side. So we're going to go ahead and do an example so this makes a bit more sense. So we're going to solve x squared minus 6x plus 4 equals 0. So we want to get that x squared plus bx form on the left side first. So we're going to move the 4 over to get x squared minus 6x equals negative 4. And then our b over 2 is negative 6 over 2 because that's our coefficient. And then we're going to square it, and that gets 9. So we add 9 to both sides. So we get x squared minus 6x plus 9 equals negative 4 plus 9. And then that gets us our perfect square trinomial on the left side. So we could write x and then whatever sign this is, so minus 3, which is the square root of 9, and then squared, equals 5. So our x minus 3 equals square root 5, because we square this, or x minus 3 equals negative square root 5. So our final answer is x equals 3 plus or minus square root 5. So the quadratic formula are the solution or roots of a quadratic equation in the form ax squared plus bx plus c equals 0, where a does not equal 0, are x equals negative b plus or minus square root b squared minus 4ac over 2a. So our quadratic formula, you could check in the textbook, they actually derive it from completing the square of the quadratic equation. Now I'm going to just have you guys take a look at it. I'm not going to have you guys solve it or try to derive it. So we're just going to be able to use it. Now I know a lot of people struggle with memorizing the formula. So when I was in school, my teacher actually came up and recorded a song. I've been trying to find it for you guys, but I haven't been able to. But what she did is think of the song Apple Bottom Jeans in your head right now, the chorus, and go through it. So basically what my teacher did is she said, okay, I'm going to take the chorus and that's going to be the quadratic formula. So excuse me trying to sing or whatever, but she used to say x equals opposite of b plus or minus square root b squared minus 4ac, and this is all over 2a, 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 2a. So that's how I, to this day, still remember the quadratic formula. So take it as it is, or if you have another way that you prefer, go for it. So we're going to go ahead and solve this quadratic equation using the quadratic formula. So we have 2x squared minus 6x plus 1 equals 0. So we know that our a is equal to 2, our b is equal to negative 6, and our c is equal to 1. So we have our quadratic equation here. So go ahead and plug in the values. So we plug in negative 6 for b. So we have opposite of b plus or minus square root negative 6 squared minus 4 times 2 times 1 over 2 times 2. So in simplifying this, we get 6 plus or minus square root 36 minus 8 over 4. So we just went ahead and multiplied the 2 times 1 is 2, 2 times 4 is 8, and then negative 6 squared is 36. So we have 6 plus or minus square root 28 over 4. We're going to simplify the square root 28, and we get 6 plus or minus 2. So we have 28 was square root 4 times square root 7. So then square root 4 simplifies to 2. Then our square root 7 we leave over 4. We're going to go ahead and factor out a 2 from the numerator. So we get 2, 3 plus or minus square root 7. And then we're able to cancel this 2 with one of the 2's on the bottom. So we get 3 plus or minus square root 7 over 2. So our solution set is 3 plus or minus square root 7 over 2. Okay, there we go. So don't forget the denominator there, even though we canceled out just 1, 2. So our discriminant of the general quadratic equation, ax squared plus bx plus c equals 0, where a does not equal 0, is d equals b squared minus 4ac. So notice that the discriminant is actually what's underneath the radical here. So this is the discriminant. So we use the discriminant to tell us what kinds of solutions we'll have to a quadratic equation. So when the discriminant is greater than 0, this means that we have 2 distinct real solutions. And then if it's a perfect square under the square root, that means it's irrational. And then if it's not a perfect square, it's irrational. Our types of solutions. If d is less than 0, we have no real solution. We'll look at in the next section how if d is less than 0, we instead have imaginary solutions. If d equals 0, that means we have exactly one solution. And it follows the same thing from when d is greater than 0 with if it's a rational or irrational solution. So we're going to go ahead and do a kind of applied example here with the path of a projectile. And so this example is found in your textbook, and I just wanted to go through it just in case it didn't make sense to you guys, or you guys kind of struggled with it, so we're going to go ahead and go through it here. So an object is fired upward at an initial speed of v0 feet per second, which will reach height h feet, and after t seconds are related by the formula h equals negative 16t squared plus v0 t. So suppose the ball is shot straight up with an initial speed of 800 feet per second, which I know is a lot. But our first question is, when does the ball fall back to ground level? So our ground level is represented by h equals 0 because we have no height here. And then our v0, we know from the given, is 800, so that's our initial speed. So we plug those into the formula that they gave us. So 0 equals negative 16t squared plus 800t. And then we're going to solve for t. So we get 0 equals, I factor out negative 16t, t minus 15. We could use the zero product property to set negative 16t equals 0 and t minus 50 equal to 0. So our t is 0 or our t is negative, or t is 50. So we know that's true because our t is 0 when the ball here is on this side. We haven't thrown it. It's at ground level, h equals 0. And then after 50 seconds, it makes its way all the way to ground level again. So our answer is 50 seconds because it wants it when it falls back down. So when does the ball reach the height of 6,400 feet? So our h here is 6,400. So we plug that into the original equation, and then we move our terms to the right side to set it equal to 0. So I went ahead and added 16t squared plus 8 minus 800t plus 6,400 equals 0. I went ahead and factored out a 16, and so I got t squared minus 50t plus 400 equals 0. I use the zero product property here after I factor, so I have t minus 10 times t minus 40 equals 0. So our t is 10 seconds, or our t is 40 seconds, and that's because it reaches the height of 6,400 feet twice. So it reaches that on its ascent and then also on its descent from the top. So t equals 10 seconds or t equals 40 seconds. I skipped c because that's similar to b, just in miles. And then our d is how high is the highest point the ball reaches. So that is going to be like our maximum. So we're going to go ahead and do negative 16t squared minus 800t plus h. And we're going to go ahead and use the determinant to find our h, when which is the solution for how high was the highest point the ball reaches. So our b is negative 800 squared minus 4 times a times c. So we're going to solve for h, and we get 640,000 minus 64h equals 0. So our h equals 10,000 feet, and that's the highest point the ball reaches. That's because when we solve for the quadratic solution, we're solving for the roots. And then we'll actually find another way to solve this we don't have to use the discriminant for, and instead we're going to solve for the maximum of a parabola, but that'll be in a later section. Okay, I'm going to go ahead and pause the video here, and then we'll continue with section 1.6 in the next video. See you then.